everyone, welcome back to another CAPSS training video. Today we'll be continuing from where we left off in the last video and build on our single axis of motion control with the aim of driving the servo motor with two of the most commonly used basic movement function blocks, MC move relative and MC move absolute. We'll also touch on global variables in order to do the initial setup for a future video where we'll be covering communications via OPC UA. We'll also finally touch off with setting the actual position of a servo and reading the actual position of a servo. So let's jump into it. As you can see, I've already begun the setup and got my MC power function block along with a axis enable local input to the POU itself. However, if I want to be able to control that via communications such as OPC UA or through other programs in the software, I'll need to make that a global variable rather than a local. So we'll start by adding a global variable list. To do this, we right-click Application, go to Add Folder, and then go down to Global Variable List. You can give our GVL a name, or just leave it as GVL, as I do. And then as you can see, we have the table of variables, which is currently empty. We can either add new up here, or just start typing in a name. We can also change the view to be structured text or tabular view. I prefer to have it as a table. So let's throw in our first variable. If you have a naming scheme which you have figured out, go ahead and use that. I'm just going to use the global input, axis enable. As you can see, we've got the data type as well as an initialization, which if I had a integer, for example, I could set that to 0 or 1. Every time the PLC starts, it will go down to that variable. If I want it to be a persistent variable, again, if it was an integer like a timer or a counter, I could keep that variable when the PLC restarts, or I can make it constant. So now that we have our global variable, we can go back and fill it into our function block. So go back to our program and just change our input variable. As you can see, it will autofill because it's part of our global variable list. And just like that, we now have a variable which we can use throughout multiple programs so that it can be controlled in more than just here. In CFC, we do not have all of the functions listed in the toolbox on the right, which is why I suggest that only people that have a bit more advanced knowledge of what the function blocks actually are use this. So in this case, we drag in a box, and then we have to name that box as a function block that we care to use. So you do have the input assistant, which you can go and look through all of these menus to find what you need. But I find that for new people that do not have any idea where things are, it can be quite difficult trying to find the function blocks that you need. So if you are new, stick to the ladder that we used in the last one. Otherwise, if you know the function blocks and know the names of them, you can cancel out of that. Just go ahead and start typing them. So in this one, I'll be using MC move relative. As you can see, it autofilled, enter. I need to give the variable with the auto declare. I'm going to keep this as a local. And just like that, we have our function block, of which we need to fill out all of our inputs. So I'll do that off camera to not bore you. However, they will be global variables so that we can use them via OPC or in other areas of the program. So I'll quickly do that. Okay, after a little bit of movie magic there, I've now got my move relative and my move absolute function blocks, as well as all of their inputs and the relative outputs that I need for this demonstration. As you can see in the global variable list, all of them are listed there. I've got their data types, and I've got some initialization values filled out. The differences between these two function blocks is move relative will move a distance from where it currently is. So if I am at 0 and I command a distance of 100, the motor will move when executed 100 of your user units in the direction of travel to get to 100. Now, if I use a move absolute, this will be an offset from where the 0 position is. So if I re-executed my move relative once I reached my position 100, it will move an extra 100, taking me to 200 of whatever your user units are. In this case, let's say millimeters. So we've moved from 0 to 100 millimeters to then re-execute to 200 millimeters. However, if I have my distance as 100 in a move absolute, because it's from the relative 0 of the actual servo motor, it will only ever move to 100. So if I need it to move to 200 from a relative of the absolute, I need to change my distance input to 200 as well. The keen-eyed among you will have noticed I did a mistake. Obviously, it was not on purpose, but it's a good example to show you how things can be corrected. So what I mean is I did a GI on the outputs of both of my function blocks. But it's a good example to see how the refactoring works. So if we go over to our global variable list, go down to our what should be a global output, change it, we get a pop-up asking us to rename. If we click on yes for the refactoring, you'll see it will change in both our global variable list and also in the PLC automatically, so that I do not have to go through the code and readdress it. So we'll go ahead and do that for the second one as well. GO, refactor, yes, click through. And we now have our global outputs correctly set and not embarrassingly done so. Also, another difference to clarify is on the distance input of the move relative. If you wish to go in a negative direction, you do have to do a negative value. So in the earlier example, if we went from 0 to 100 millimeters with a value of 100 in the distance, if I wanted to then go back to 0 or go negative 100 from wherever I am, I would have to enter the value negative 100. Simple as that. Cool. Now we have all of our movement function blocks assigned and working. We can add in our MC set position and our MC read actual position as well. So drag in some more boxes. MC read actual position. Yes. Drag it to position. Give it our axis. And for this one, I just want it to be true all the time because I always want the position to be read. And then we are going to create another global variable. So GO, axis, act, position. Make sure it's a long real. And go back to our software. GO, axis, actual position. Cool. And then we want to drag in a set as well. So MC set position. Define that too. Drag it up. Define the axis. We want to do a set as well for the position as well as the execute. So we'll create 2 extra ones. So GI this time. Axis set pos. Make that a bool. A bool. And then another one for GI axis set pos. Gonna be lazy, call it position. Call that one execute. Refactor, yes. Change this one to now real. Done. Right. For our program, I'm going to throw them in. So GI, axis set position, execute, and then GI, axis set position, position. Okay, now we have our actual positions and set positions in place. We can go ahead and compile and make sure that the software is all okay. There's no errors. And then I will show you how to do a simulation so that you do not have to run the actual hardware and you can do tests before you get hardware. Or if you just intend on getting used to the software, you can do simulation modes and decide if the software is good for you. So first of all, we need to set the access to virtual mode. So we go to access on the actual servo motor itself, general settings, and tick virtual mode. And then in the online section, we need to checkbox simulation. So now when we do our login, it will ask us to download to the sim device. So I click yes. And that now takes us online and obviously immediately downloads to the sim device and in the stop mode. So if I start the PLC simulation, we can now see the live states of these. So I will enable my access just like I did in the previous video. As we can see, access power is true. Our position on our actual position is 0. However, if I want to continue watching this position so that, you know, when I'm diving through other programs and doing debug, etc., if I don't have my eye on the HMI, which is what this is intended to go to, we can add it to the watch window, which we have down here. So if I right click the value, I can do add watch, and now my position appears in the bottom. So now we can start trying to test our moves and see if they work. So if I go to my move relative distance, I can double click on that, enter in a value. I already have velocity, acceleration, and deceleration from my initialization. So I'm going to push in my distance, which changes that. And then I will give an execute. And because my power is already on, my servo motor moves in simulation to position 100, as we can see. If I drop my execute and re-execute, my servo motor actual position moves to 200, just like I demonstrated in our earlier conversation. So I'll drop that back to 0. If I wanted to then pull it back to 0 from its current position, enter in -200, execute at the same time, and then bam, it goes back to 0. So the differences between these function block inputs is that on our MC power, we must keep this high as it's an enable input, but on our execute, we only need a rising signal. So if I kept that true, this will not re-execute that function block on any of the next scans. So when the execute goes high, this function block takes a snapshot of everything on the input side, so distance, velocity, accel, decel, jack, buffer mode. It will then process that information, create a move profile. So in this one, it will be a trapezoidal move. So we've got the 0, acceleration, normal move speed, and then deceleration down to 0 again. So I need to always drop the signal and then pick it back up to get the motor to move again. So take that into account when you're writing your sequencing. The move absolute works exactly in the same way, but obviously only moves absolute to the 0 of the servo motor. So in this case, I have 0 in my distance. So if I enter in a true value on the execute, you can see my servo motor moves to the 0 position. However, if I then re-execute that, because the servo is already at the 0 position, it will only ever move to the 0 position. So you can use that as a home just to double confirm that you are at a position before you start a sequence as well. At least that's what I like to do. So now that we have that as our position, we can go ahead and look at setting our 0 position, but we can also do offsets. So at the moment, if I was to execute this function block here, because my positional value is a 0, when I execute that, the actual position will update to 0, which we obviously already have. The good thing about this is if you're doing something like an offset from a proxy sensor, so if you're creating your own homing function and you want the 0 from the proxy sensor to be, let's say, 10 millimeters out from where it actually is, I can have this position change. So if I double click that, I can change the value. Obviously, if yours is a fixed value, you're going to set that in your initialization. So if I set this now to true, see my actual position changes to 10. And I can unexecute that to reduce it. Okay, we'll quickly dive into a topic that tends to trip up new people that I train all the time. So that is the relation between distance, velocity, acceleration, and deceleration. So I'm just going to take it very basic and try and give you an understanding so that it doesn't trip you up as well. So each of our servo motors have a trapezoidal move. What that means is we have a moment of standstill, we have our acceleration, and then we have our nominal speed, our deceleration, and then back to our 0 speed. So this can be split up into sections of what our actual distance, velocity, accel, and decel are. So our distance is this area here, so the entire thing. Then we have our acceleration period, which is this. And then we have our deceleration period, which is this. So given those values, the function block, as I said, will calculate this move profile and give you an output move when executed. However, things that can catch you out is that if you have a velocity that is too high or accelerations that are too low, you can meet behavior which will be undesired, we'll say. So for an example of this is if my velocity is, let's say, 10,000 and my acceleration and deceleration are only set to 10, what will happen is that our velocity set point, which is all the way up here, because our acceleration and deceleration are too low, the actual profile that we'll end up getting will look something like this, where we've just got a triangle rather than meeting our nominal speed and our trapezoidal. So that triangle will show you that the nominal speed that we care for is way, 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 way up here, and we're never reaching that. So you increasing the velocity to try and speed up a motor is never going to do anything. You will have to increase your acceleration and deceleration to actually achieve the speed that you are commanding already. So make sure that the relationship between the velocity and the acceleration are correct. I tend to have the acceleration and the deceleration on a move that isn't supposed to be violently fast, maybe a factor of 10 or 100 more than what the velocity actually is. So this just comes with experience and knowing how the servo motor sounds against the mechanics of the machine. So changing things like ball screws, etc., linear drives, they have different parameter sets that you can tweak to be able to change this, as well as tuning that has an effect on it as well. But those are all, again, a couple more advanced things to dive into that we won't cover here. Okay, and just like that, we've turned our servo motor on. We've moved it relative, both forward and reverse, and we've done move absolutes, so we understand that, and we know exactly how the move MC set position works, as well as reading the actual position and monitoring that actual position all the time when we're diving through other pieces of code. So I think that will be all we will cover today, just to not complicate things. However, in the next video, we're going to be covering symbol configuration and OPC UA setup, so that it will allow us to do some basic HMI control. So stick around, come back, visit, and I'll see you next time. Ciao.